Hello everyone, my name is Saket Kumar Singh. I am working as an assistant professor in Department of Computer Science Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. In this lecture, we are going to see what are the RAID labels. RAID labels. I hope you have already seen some of the disk structure, that what is the structure of an hard disk. Okay, and you would have already seen some of the disk scheduling algorithms like SSTF, shortest seek time first, FCFS, scan, C scan, look, C look. So I hope you have already seen all these. So in this lecture we are going to see what are RAID labels. Okay, so now let's come to the outline of this lecture. So what we are going to see in this lecture: first I will give a brief introduction about what is RAID, and then how we can improve the performance of a disk, how we can improve the performance of a hard disk. Whenever I am talking about a disk means secondary storage. So we have already seen some of the memory hierarchy in our chapter 1. So you have already seen that registers, the CPU registers are termed as very fast. Then in the hierarchy it was like the thing was cache memory, after that main memory, and then magnetic disk or magnetic tapes were there. So these magnetic disks are considered to be your hard disk or the secondary memory. Okay, so how to improvise the reliability, how to improve the reliability of the hard disk, how to improve the performance via parallelism, that we will see in this lecture. And now what are different levels of RAID are existing right now. So we will see what is RAID level 0, what is RAID level 1, what is RAID level 2, what is RAID level 3, what is RAID level 4, 5, 6, and 0 plus 1 and 1 plus 0. So now let's start about the introduction to RAID. What is a RAID? Okay, so let's see that smaller and cheaper disk drives nowadays has given idea to attach many disks. Okay, so the disk cost is reduced up to a very low level when you compare the hard disk cost with the RAM cost or the main memory cost. You find it very less, because even you can get a 1 TB or 2 TB hard disk around 3k or 4k or 3000 to 4000 of rupees. But when you talk about a RAM, you will get around 8 GB of RAM. 8 GB of RAM will cost you the same as 1 TB of hard disk. So the hard disk cost is very cheaper now. It has been reduced to a very low, and you can see this has provided the programmers, the computer engineers to attach many disks. Many disks can be attached in a single. So as to what is the aim of attaching many disks? To improvise the performance of the hard disk. Okay, so parallel disk improves the rate at which data can be read or written. Okay, so whenever we will use parallel disk, suppose that earlier we were using only one hard disk. Okay, suppose that if I am going to use 3 hard disk parallelly, so that will improve the rate at which data can be read or write. Okay, now improves reliability as data is stored in multiple disks. Suppose if I have stored some of the movies or some of my very important files in this hard disk A. Okay, and suppose that if my hard disk is this A hard disk is crashed now, what will happen? My data will lose. I will lose my data will be lost. Okay, but suppose that if I am using 3 hard disks, of course that will improves the reliability, because the tendency of loss of data will be reduced. Okay, how? Because I have copied this important file in disk A as well as disk B as well as disk C. So if suppose that this A hard disk is crashed or something, I will not lose my data. So of course improves reliability as data is stored in multiple disks. Okay, so failure of one disk does not lead to loss of data, that we have already seen. Okay, now various disk organization techniques are collectively called as redundant arrays of inexpensive disks. Okay, so what is the full form of RAIDs? What is the full form of RAIDs? Redundant arrays of inexpensive disks. Okay, so you can see this is the redundant array of inexpensive disk. So instead of using only one hard disk, what we are using? We are using 4 hard disks. Okay, this is just a simple example that I have drawn here. But yeah, what is a RAID? RAID is redundant arrays of inexpensive disk. That means we are not using only single hard disk, we are using parallel disks, we are using parallel arrays of disk instead of using only one disk. What is the aim behind this? To improve the performance, to improve the reliability of the disk. And earlier it was not possible because the disk was very costly, the hard disk was also very costly, but now as the disk cost has been reduced, now we can use a bulk of some number of hard disk parallelly. Okay, so now these are commonly used to address the performance and reliability issues. These are the main aim behind using this RAID is it addressed to address the performance and reliability issues. Okay, now let's come to some more points, like earlier RAIDs viewed as cost effective alternative to large expensive disk. Okay, so earlier when the hard disk cost was not so low, at that time we used RAID as a cost effective alternative to large expensive disk. Okay, instead like applying a large costly disk, we can use a less cost a small disk in place of one large disk. But as disks were small and cheap, okay, so RAID was called as redundant array for inexpensive disk. RAID was called as redundant array for inexpensive disk. Now RAIDs are used for their higher reliability and higher data transfer rate. So RAID now stands for redundant array of independent disk. Okay, so when the hard disk cost was not so low, at that time we were using this RAID as a redundant array of inexpensive disk. Okay, inexpensive disk. But now we call RAID as a redundant array of independent disk. Okay, so now that inexpensive word has gone, and in place of that inexpensive we are using this independent. Okay, so what is the benefit of using this RAID technology? It improves reliability, that we have seen in our first slide also. Chance of failing some disk in set of n disk is much higher than the chance of failing single disk. Of course, when we talk about probability, if I am using a single disk and I am using n number of disks, if suppose the probability of failing one disk is more probable as compared to set of all the n disk will fail. Okay, now suppose that the mean time to failure of a single disk is 1 lakh hours. Okay, so this is a scenario. Okay, and then the mean time to failure of some disk in an array of 100 disk will be 1 lakh divided by 100, that will be 1000 hours or 41.66 days. So if you will calculate the mean time failure, mean how much time how much is the disk is going to leave. So if you want to calculate the mean time of when the disk will fail, so if you will take around 1 lakh, suppose that the mean time of failure of a single disk is 1 lakh hours. Okay, suppose if I am using a single hard disk and the lifetime for that hard disk is given, the warranty or the guarantee of that disk is given as 1 lakh hours. Okay, then the mean time to failure of some disk of array of 100 disk will be 1 lakh divided by 100, that is your 1000 hours, or 1000 hours approximately when you will calculate in days, it will be like 41.66 days, which is not so long at all. Okay. So, when just as a comparison, just we have taken a scenario and just calculated the probability of how much a single disk can leave when we are comparing it with the n number of disks. Redundancy has proved to be a solution. Okay, redundancy, when we apply redundancy, means just copying one data in 2 or 3 or more than 3 locations. So, that will provide us the reliability. Okay. Some extra information may be needed in situation of failure to rebuild the data, like we will see later on in RAID level 0 or 1, that how parity bits are used, how parity are used to rebuild the data in case of failure. So, some extra information may be needed in situation of failure to rebuild the data, but yes, we can provide solution to the problem of reliability by providing redundancy. Okay. Improvement of reliability, redundancy can be achieved by mirroring. So, what is mirroring? Mirroring means copying the same data into more than 2 locations is called, or more than 1 locations is called as mirroring. Okay. We will see the definition later on in this subsequent slides. A logical disk then consists of 2 physical disks, and every write is carried out on both the disks. Okay. So, this is the, you can say, a scenario of how mirroring is done. A logical disk then consists of 2 physical disks, and every write is carried out on both the disks. Okay. If one of the disk fails, the data can be read from the other. Data will be lost if the second disk fails before the first failed disk is replaced. Okay. So, data will be lost only if the second disk fails. Data will be lost only if the second disk fails. Okay. So, only if the second disk fails before the first failed disk is replaced. Like if you are using 2 hard disks, and then what is the scenario when my data will be lost? If both of the disk is failed. Like suppose that if I am using this hard disk A and using this hard disk B, if suppose A has failed, B is having the copy. Okay. So, if using this B, if you can recover this A, then no data loss will happen. But suppose that before rebuilding this hard disk A, before recapturing the building this hard disk A, this B also fails, then only the data loss will happen, otherwise both will be rebuilded. Now, power, there are several other scenarios where also we can face this data loss problem, like power failures and natural disasters such as earthquakes, fires and floods may result in damaging to both the disk. If you are using mirroring, if you are applying copying of data in more than one disk. So, these are earthquake, for these problems may also affect the both the disk. At the same time, also manufacturing defects in batch of disk can cause correlated failures. Even suppose that wherever the disk are manufacturing, if the whole lot of manufacturing unit is bugged and the product is not coming well, that is also a problem of the disk failure. As disk ages, the probability of failure grows. Suppose that I have bought a hard disk at around 2002. So, the number of years it will increase, the probability of failure of that hard disk will also increase. In spite of all these considerations, however, mirror disk system offer much higher reliability than do single systems. Obviously, this is very true, because if I am using a single system, single disk system, mirroring is better solution as compared to using a single disk system. Okay, improvement in performance via parallelism. So earlier in previous slides we have seen how to improve the performance via reliability. Now we are seeing how to improve the performance via parallelism. With disk mirroring, the rate at which read request can be handled is doubled. Okay, whenever you are copying the data in two disks, suppose I am taking an example like example of hard disk A and hard disk B, you are using two disks and you have copied the same data in both of the disks, that is the mirroring. Okay, and now what will happen, but when you will use this disk mirroring, what will happen, request can be the rate at which read request can be handled is doubled. Okay, the transfer rate of each read is the same as in the single disk system. Okay, transfer rate is same. If you are using one disk or two disk or three disk, the transfer rate will be same, but the number of reads per unit time has doubled now, because you are using two disks in place of one. Okay, transfer rate can be improved by striping data across the disk. You can improve the transfer rate by just dividing the data into blocks and then spread it in different disks, that is called as the striping. Okay, so transfer rate can be improved by striping data across the disks. These are of two types. One is your bit stripping, consists of splitting the bits of each byte across the multiple disks, that we will see on the basis of this. On the basis of this only, there are 6 levels of RAID, 6 levels of RAID that we will study. Okay, so bit striping consists of splitting the bits of each byte across multiple disks. Okay, block level striping means, block level striping consists of splitting blocks of file across the multiple disks. Okay, so suppose that you are having a block that is of 8 byte, okay, or simply say it as 1 byte. You are having a block of data of 1 byte. Okay, so now what will happen if you are using a 1 byte data? So you are just spreading this 1 byte into, suppose you are having 4 disks. So one you will keep here, 1 bit you will, when you are using bit stripping, then 1 bit you will keep here, 1 bit you will keep here in this hard disk B, 1 bit you will keep in this hard disk C, 1 bit you will keep in this hard disk D. Okay, similarly there are 1 byte, that means 8 bit will be there. So in this way you can do the bit stripping. And in block stripping, suppose you are just dividing the whole block and then spreading it in different multiple disks. So let's see what is RAID levels. Mirroring, we have already seen that mirroring provides high reliability but is expensive, as you have to use n number of disks. Okay, and striping provides high transfer rate. Striping provides high transfer rate but it's lack reliability. Reliability means, suppose that this was your whole bunch of data and you have divided into blocks and you are just keeping all the blocks in different locations, like this block you are keeping in hard disk 1, this block you are keeping in hard disk 2, this block you are keeping in hard disk 3, this block you are keeping in hard disk 4. Okay, now suppose if any disk will fail, your data will be lost because you have divided the data into blocks. Okay, so mirroring provides high reliability just because you are copying the whole bunch of data in different hard disk. Striping provides high transfer rate but it's lack reliability. Okay, so now numerous schemes called RAID levels are used, which combines disk striping with parity bits to provide redundancy. So let's see what is the first level of RAID. RAID level 0. Let's see. So what is RAID? RAID is combining all those. What are these RAID levels? To combine both the things. First is your mirroring and then striping, and we'll see different types of RAID level by which are using the combination of both the mirroring and the striping. Okay, so this RAID level 0 is what? It is, let me use the eraser first. then it will be more clearer when we will see the figure of this RAID level 0. Okay, so now what does this RAID level 0, how it works? So let's see, it uses block level data striping, means the data has, the whole bunch of data is divided into blocks. And what are the characteristics of this RAID level 0? If one disk fails, data loss will happen. Why? Because striping provides high transfer rate, but it's lack reliability, as you have divided the data into blocks and keeping it in a different disk. If any one disk will fail, data loss will happen. Storage capacity is 100%. Yes, because in all the disk you are keeping, all the disk you are keeping the data, you are not using any parity or any other extra information. Okay, so let's see, this is the example here, drive 1 and drive 2. So just see how the data is divided into two disks. So this is your block 1, this is your block 2 of a same data. Block striping means you have divided the data into blocks and you are keeping both the blocks in different drives. You can see this is your drive 1, this is your drive 2. Okay, so you can see this, the block 1 has been kept in drive 1, block 2 has been kept in drive 2, block 3 in drive 1, block 4 in drive 2, block 5 in drive 1, block 6 is drive 2, block 7 is in drive 1, block 8 is in drive 2. Okay, so you can see if this disk is failed, so there is no way to get the data back. Okay, the data loss will happen. Okay, so this is the disadvantage of RAID level 0. Now we will see RAID level 1. What is RAID level 1? It is very simple. It applies mirroring, maintain a copy of data. Okay, so we know that when we are using mirroring, it increases the reliability because the data loss will not happen, but the data transfer rate will be very slow, as you have to copy the data in both the disk. All the read request and all the write request is doubled now. Okay, so storage space can be used only 50%. How? Let's see. If you are using a single two disk, you have to copy your data in both of the disk. Okay, so you can see block 1, 2, 3, 4, block 5, 6, 7, 8. These were your two disks, and you have applied mirroring in disk 3 also and in disk 4 also. So this is your RAID level. This was your RAID level 1. Now we will see on RAID level 2. What is RAID level 2? Bit stripping with parity is used. Bit stripping with parity is used. So now we are using both the things. When we are using bit stripping means we are dividing the data into bits, the smallest unit. That is, we are dividing the data into bits and we are keeping all those bits in different hard disk, and we are also using parity. Parity is being used. Parity, you can consider it as an extra bit that we are using to retain our data if some data losses happen. If some disk fails, then with the help of this parity we can rebuild that disk, we can recapture those data that was lost. Okay, parity is a simple technique to detect and correct error. Extra disks are used to contain parity information, like we can see by the diagram. Disk 1, 2, 3, 4, and this is the disk 5, which is an extra disk, are used for the parity. Disk 5, disk 6, disk 7 will hold the parity information. How this holds the parity information? Like suppose number of bits in byte set to 1 is even, like if you are using 1 1 1 1 0. So this is a byte set which are having an even number of 1. Then if your data is having even number of 1, then the parity will contain 0. If the data will contain odd number of 1, the parity bit will show 1. Okay, if one of the bit is damaged, like suppose while transferring, if this bit is damaged now and now this will show 1, so what will happen? Parity of the byte will change and does not match with the parity of the byte will change and does not match with the stored parity. Okay, if stored parity bit are damaged, then it will not match with the computed parity. Like suppose if this stored parity is damaged while copying, then it will not match with the calculated parity. So, we can detect the error if some error has happened while transferring the data. Now, in RAID level 3, what we do in RAID level 3, it is also known as bit interleaved parity organization. This controller can detect whether a sector, at that in previous RAID level we are dealing with the bit level, now here we are dealing with the whole sector. This is in this byte striping is used. This controller can detect whether a sector has been read correctly or not. Okay, so you can see the diagram. So, even a single parity can help in this. You can see only a single parity, because we are not dealing with the bit wise, we are dealing with the whole sector. So, for a whole sector, if any damage is happen, we can check with this single parity bit. Only single parity bit can be used for error correction as well as detection. Byte level striping is used in this level, RAID level 3. Now, what is RAID level 4? It is similar to RAID level 3, but here instead of using byte level, we are using block interleaved parity organization, means we are using blocked level striping. Uses block level data striping like all the disk will contains B1, B2, B3, okay, B1, B2, B3, B4 and the parity bit. So, both the RAID level 3 and RAID level 4 shares the same disadvantage, like if this parity disk will fail, then you will not be able to regenerate the data, because your parity bit has data hard disk is failed now. So, but even in this RAID level 4 also this is the disadvantage. Keeps parity block on the separate disk. If one disk fails, parity block from other disk can help restore the block of failed disk, but what will happen if this parity disk will fail? Okay. Now, what is RAID level 5? RAID level 5, in which block interleaved distributed parity, means the parity has been distributed to n number of disks, not in a we are not keeping the parity bit in a single disk, we are distributing the parity in n number of disks. Okay. So, this will be clear when you will see the diagram. Okay. It spreads data and parity among n plus 1 disk, require at least 3 hard disks. Okay. For example, with an array of 5 disks, the parity for the nth block is stored in disk n mod 5 plus 1, n mod 5 plus 1. Okay. So, a parity block cannot store parity for all blocks in same disk, as disk failure will result in loss of data as well as the parity. Okay. So, suppose that this is your B1, B2, as this is a block level striping. Okay. So, you will not keep B1, B2, B3 in the same manner. In the second disk you will keep B2, then B3 and then B4 will come here, and then B5 whatever B6, B8, B7 will come here, or B8 will come here, and the parity bit. So, this parity is not holding the parity information for the same disk, it is holding parity information for some another disk, that is calculated with the help of this n mod 5 plus 1. Okay, you can see disk 2 is holding the parity information of disk 1, disk 3 is holding the parity information of disk 2, disk 4 is holding the parity information of disk 3 and disk. In this manner these disks are arranged. Now, you can see what is RAID level 6. RAID level 6 is block striping with double distributed parity is used. We can directly see the images to understand this. You can see instead of parity, error correcting codes like Reed-Solomon codes are used in this. It can tolerate 2 disk failures. RAID level 5 cannot tolerate 2 disk failures, but this can tolerate. Okay. Now, the another level is RAID level 0 plus 1 and 1 plus 0. So, 0 plus 1 refers to combination of RAID level 0 and RAID level 1, and similarly 1 plus 0 is refers to combination of RAID level 1 and RAID level 0. RAID level 0 provides performance, while RAID level 1 provides reliability, and it is very expensive. A set of disks are striped and then the stripe is mirrored to equivalent stripe. Okay. In 1 plus 0, disks are mirrored in pairs and then resulting mirrored pairs are striped. Okay. So, this is the combination. So, that is all. Thank you.